All right, please make sure you remember that as pressure increases, volume decreases. Okay? With temperature, as temperature increases, volume increases. So these here are inversely proportional, these are directly proportional. Okay? So, what I want to do is just go over a few of the gas law problems with you. And if you look at this first one, it says determine the volume of a 1.5 atmosphere gas at 20 degrees Celsius and 30-liter vessel is heated from 30 degrees Celsius at a pressure of 2.5. Here's the key. Anytime you're dealing with a gas law, you have got to be in Kelvin. So the first thing I want you to look at So the first thing you have to do is convert your temperatures to Kelvin, okay? So the 20 plus 273 is going to give you 293. And then 273 plus 30 is going to give you 303. All right, so now sub in. Here's your formula for the combined gas law. Your P1 is 1.5. Your V1 is 3. And it's divided by 293. And that equals, we don't know our volume, but we know that the pressure is 2.5 and that it was heated to 303. So when you calculate that, go ahead and calculate the one side. And then multiply that by the temperature of the other one. That gets rid of it so that you're isolating your variable. And now divide completely by 2.5. Oops, I didn't. And that should give you an answer of 1.86 liters. Okay, so that's how you do those problems. When you're looking at Graham's law is about which one goes the fastest and how much faster. So which gas is going to go faster? Cl4 or Br2? Well, you've got to get the molar mass. The one with the smaller molar mass is going to go faster, okay? Now, how much faster is hydrogen gas than sulfur trioxide gas? So you're going to get the mass of sulfur trioxide, and I don't have my periodic table to have this while I'm doing this, and then you're going to get the mass of hydrogen. You take the square root of that, and that tells you how much faster it's going to go. All right, ideal gas law. What you're doing in ideal gas law is you're using the formula PV equals nRT. So the first thing I want you to do is make sure you look at your pressure value, and that's going to determine which R value you use. So the question says, how many moles of oxygen will occupy a volume of 2.5 liters at 1.2 and at 25 degrees Celsius? So first of all, go ahead and get your temperature. So 25 plus 273 is going to give us 298. We know that we're in atmosphere, so we're going to use the R value of 0.0821. We don't know our N, but we know that we have a pressure of 1.2, and we know that we have a volume of 2.5. So figure out, 1.2 times 2.5 divided by the 0.0821 times 298. You should get 0.1 moles. So that's how you do the ideal gas law. All right, under Dalton's pressure is just simply adding up if you want to know the total, or you subtract if you want to know the partial pressure. So if I know that the total pressure of gas is 75, So what it's asking, I'm sorry, what is the total? So I know I've got 75 plus 120 plus 33. So my total pressure is going to be 228 kPa. All right, so that's Dalton's law. Dalton, you add them all up or you subtract if you're using the pressure.